All right, this is our last example. So now looking at this quadratic expression, I can see that there's no greatest common factor, so there's no greatest common number that would divide 7, 45, and 28 evenly, versus in the example before where we had where we could divide each of those terms by 3 to pull out the greatest common factor. So now what I'm going to do is I'm going to actually go in with the generic rectangle method to solve this problem. And it's going to be a little bit more time consuming, but that's okay. So in this corner, I'm going to put the x squared terms. This corner is for my constants. And now for the product of the x squared term and the constant, 7x squared times negative 28 is negative 196x squared. And notice I am going to use my variables this time around because all of the calculations are a little bit more complex. And the coefficient of the x squared term is no longer 1. Now the sum is the middle term, which is negative 45x. Now, of course, it's going to take us some time to figure out the two factors that you multiply together to get negative 196x squared. Those factors are negative 49x and positive 4x. Okay? And then negative 49x plus 4x gives me negative 45x. I'm going to transfer those into my generic rectangle to find the dimensions of it. Okay? So now I know that if I multiply 7x times x, that's going to give me 7x squared. If I multiply 7x times negative 7, that's going to give me negative 49x. If I multiply x times 4, I'm going to get 4x, and then 4 times negative 7 is negative 28. I have found my dimension, so I can represent this expression as the product of two binomials. Okay, so it'll be 7x plus 4 for the first one, and x minus 7 for the second one. And that is all. Second happy face.